The lines in the graphs appear to intersect at a point on the graph. Where do they appear to intersect? So let's zoom in. So intersect means where they cross. Now that place of crossing appears to be right there. And the question is, how do I say right there? How do I tell the world where right there is? Well, we can use our ordered pair notation. So one way to say is, oh, well, it's where x is 1 and y is 7, which we could write as an ordered pair of just 1, 7. So they intersect at 1, 7, where x is 1, again, where this is our x-axis, and this is our y-axis. Because when I put x as 1, I get 7 for y on both of these lines, which represent equations. Right? Just to be clear, right, this blue line is represented by 5x plus 2, and the red line is represented by negative x plus 8 equals y. So, how can you prove that that is in fact where it is, and that it's not slightly to the left or slightly to the right, or that my label is wrong? You know, how do I know my eyes aren't playing tricks on me? Well, remember that my input is 1, and my output is 7. When I put 1 in for x, I get 7 out for y. Well, is that true for both of these? For y equals 5x plus 2. When I put in 1 for x, do I get 7 out for y? Is that a true equality? Well, 5 times 1 is 5 plus 2. Is 5 plus 2 7? Yes, it is. So it's definitely a point on the blue line when x is 1, y is 7. What about on the red line? For y equals negative x plus 8. When x is 1, is y 7? Well, this is 7. Is a 7 equal to negative 1 plus 8? It is. So for the blue line, where x is 1, y is also 7. So if you looked at it in tabular form, in a table, maybe I'll call this y1 for the first equation. Or let's not get simplistic. Let's write it out. So my x value, this is y equals 5x plus 2. This is y equals negative x plus 8. So when y is 0, or when x is 0, this is 2 and this is 8. But when x is 1, these are both 7. And when x is 2, that's 12 and that's 6. So you notice there's only one place where the same x gives me the same y for both. And that is an intersection. That's what an intersection means. It's where the output is the same for the given input. It's where they behave the same. Maybe not all the time, but for one particular moment, for one particular input, they do the same thing. They are equal. So that's how you can interpret this graph.